So this is duration is 30 minutes. Okay. So online, are you clear?
Yes, sir.
Okay. So you have to see the screen. No?
Yeah, sir.
So this test duration is 30 minutes. Time starts now. 4:34 is the time. Within 5 complete. That's
Excuse me, sir. Sir, can you hear me?
Yeah, tell me.
Sir, the graphs, rest, uniform, and accelerated motion, you are given down below V to U and A to U. Is it for respectively rest and uniform?
The VT graph and AT graph for all the three scenarios.
Okay.
Velocity time graph for rest, uniform motion, and accelerated motion. AT graph for rest, uniform, and accelerated. Got it?
Okay. Okay.
Good fast. Can you 5 more minutes time? Good fast. That's the most. Done?
Yes, sir, done.
Next, go to test one. Next, So any doubts that you have now? You wrote, since you wrote test now. Any questions that you have? Well,
Sir,
right,
I'm
did
not
you get
sure
any
about
doubts?
my accelerated motion graph.
I didn't get you.
No, sir, I'm not sure about my accelerated motion graph. That alone, sir.
Okay. So those are online, are you able to see my screen?
Yes, sir.
Okay. Rohit, you joined late, no? So try to understand. If you have any questions, please stop me, okay? Ready, Abba? Can you come this way? My camera is recording. You will be able to see from there, no? Pulamada, we'll get started. Right. So let's look at the problems based on one-dimensional motion. Okay. So the first question here is, in figure 3.12, this one, there is a particle which moves along a circular path of radius r. Okay. It starts from point A and moves in the anti-clockwise direction. Okay. Find the distance traveled by the particle. In that, the first question is as it moves from A to B. Secondly, as it moves from A to C, similarly A to D, and when it completes one revolution. So that is the first part of the question. The second part of the question is also find the magnitude of displacement in each case. Okay. So in the first part, what are they asking? When they say find the distance traveled, okay, I thought they asked path traveled. Find the distance traveled by the particle when it goes from A to B. So when I say distance, the direction along which the path which is taken by the particle is very, very important. Right? So when it is going from A to B, when the particle is moving from A to B, how much is the distance it is covering? It's very simple. It's very simple. If it is a complete revolution, how much is going to be the circumference? So when it goes from A to B, it completes 1/4 of a circumference. Right? The question is very simple. Okay. So now you know what is the circumference? 2 pi r. So 2 pi r by 4, which is equal to pi r divided by 2. Okay. See, this is one way. How many of you know radians? Like I've explained the concept, right? So what is radians actually? Can you tell me what is the definition? For those who don't know, listen to me. Radian is basically arc length divided by the radius, right? So in this case, the arc length in each scenario is the distance. So arc length is equal to radius into radian. So what is the radius of this circular path r? When it goes from A to B, what is the radian it is covering? So it is basically pi by 2r. This and this will give you the same answer. Are you able to understand? So you can solve the problem in either of the ways. Both are related. That's how you get it. Okay. Similarly, when the particle moves from A to B, how much is the distance covered? It's very simple. See, if you don't know this method, it's fine. It is just for knowledge. Okay. So you can still go with the first method, which is simpler. Right. So this is slightly, maybe you can, if you're interested in angles and everything, you can think in this way. That is what I wanted to show. Here. So tell me, what is the distance it covers when it moves from A to C? 2 pi r by 2. So when the particle goes from A to C, the distance covered by the particle is pi r, because it's half of a circle or a semicircle's length. Right. Then when the particle moves from A to D, so when the particle moves from A to D, what is happening here? It is covering pi r. So this length is pi r plus pi r by 2. So can I write it as pi r plus pi r by 2, which is 3 by 2 pi r. Whose phone is ringing? Someone's phone there. Huh? Okay, it's fine. So I hope you could understand these three, no? Fourth one, when it completes one revolution, obviously 2 pi r. So when it is going to complete one revolution, it is going to be 2 pi r, right? So the next part of the question is also find the magnitude of displacement in each case. So when the particle goes from A to B, what is the displacement? What do you mean by displacement? It is the shortest path length. So what are we supposed to do? Join the points A to B. When you do this, what is going to be the displacement? Tell me. If this is the radius, this is also radius, it forms a right angle triangle. So it is going to be root 2 r. Root 2 r then. I'm not showing you how you got that root 2 r. Basically, it is a square plus b square under a root. So root 2 r. Similarly, what is the displacement of the particle when it moves from A to C? R plus r. So when the particle moves from A to C, the displacement is going to be 2r. Similarly, when the particle moves from A to D, when you join this, the displacement is still going to be root 2r. Right? When it completes one revolution, so when one revolution is completed, the answer is going to be 0. Am I clear with this? So don't write the question, make a note of the solution of it. This sheet will be shared with you after the class. Right angle triangle, though. Pythagoras. So if I look at this, this is r, this is r. This will be root of r square plus r square. So it is root of 2r square, which will be root 2. Clear with this? Shall I proceed? Those are online. Shall I proceed?
Yes, sir.
Okay. So this is the solution. You guys wrote it, huh? Finished? Okay. So let's look at the next one. A car is moving along x-axis. Okay. As shown in figure 3.13, it moves from point O to P in 18 seconds. So when it goes from O to P, it takes 18 seconds and returns from P to Q in 6 seconds. So this is one way, this is the reverse journey. The next question is, what are the average velocity and average speed of the car in going from O to P and from O to P and back to Q? So it's an NCERT problem. So first thing we need to recollect, what is average velocity? So when I talk about average velocity, it is going to be the total displacement divided by the total time it takes. So whether it is going to be distance or displacement, the time is going to be still 18 plus 6, which is going to be 24. Right? What happens in the case of displacement when the particle goes from O to P? Oh, 1 minute, I'm sorry. So when the particle goes from O to P, things are different. When it goes from O to P, the total time is not 24, it is only 18. It is only 18. So what is going to be the total displacement from O to P? Right, it is 18 seconds, 360 meter. So 360, it is going to be 20 meter per second. Okay, accepted. What about the average speed? Average speed is going to be total distance by total time. So in this scenario, what is going to happen is, since there is no change in direction took place, when the particle went from O to P, since there is no change in direction, distance and the displacement are same. So you will get the answer as 360 by 18 only, which is still going to be 20 meters per second. Am I clear with this? Right. Whereas when the particle goes from O to P and back to Q, I'll call the journey as O to Q, where it is going to be a return journey. Can I say that? Right. When this is so, it is a journey from O to Q, which is a return journey. Now, what happens to the average velocity? Formula is the same. Total displacement by total time. So what is the displacement of the particle? From O to Q, the displacement is 240. So it is going to be 240, but the time is going to be 18 plus 6. It is going to be 24. So average velocity will be 10 meters per second. It is decreasing because of the change in direction. So that's obvious, right? It should decrease because of the change in direction. What about the total? Sorry, what about the average speed? So when I talk about average speed, it is going to be the total distance by total time. So total time is still going to be 24 only, but the total distance is going to be O to P 360 plus from 360 to 240, the difference is 120. So 360 plus 120 is going to give us 480. So it is going to be 480, hence the average speed is maintained at the same value. You're clear with this? So these are the velocities for different scenarios. make a note. Yeah. So the next page point also you wrote it. Shall I proceed? So this one, are you done with? So there is, the next question is, an object travels from A to B at 40 meter per second and from B to A at 60 meter per second. Calculate the average speed and average velocity. So there are 2 points, A, B, and when the particle travels from A to B, it travels at a speed of 40 meter per second. And when it travels from B to A, it travels at a speed of 60 meter per second. Calculate the average speed and average velocity. So what is the average speed here? So average speed is equal to correct. But what is the challenge here? You don't know the distance and you know the time. Right. So how do we solve this? I think there is something missing in the question, but let's see. So if I take the distance to be D, okay. If I take the distance from A to B as D, how much will be the value of D when the particle goes from A to B? So when the particle goes from A to B, we know that distance is equal to speed into time, right? So what is the speed? It is 40 into T1. Accepted? Similarly, when the particle goes from B to A, the distance is still going to be D. But what is the? So it is going to be 60 into T2, right? Which implies T1 can I write it as D divided by 40? And T2 can I write it as D divided by 60? Now our job is easy. How? When I say the total distance, it is going to be D plus D, which is 2D, the whole divided by, the total time is going to be equal to T1 plus T2. So it will be D by 40 plus D by 60. So one variable is there, it will get eliminated, right? So observe, this is going to be 2D divided by, if I take this D by 10 outside, even I can take 20 outside. Okay, then it will become half plus 1 by 3. Make sense? So D and D will get cancelled. So LCM, if you after you take LCM, it will be 5 by 6. So 5 by 120. So that will go to the numerator. So it will be 240 divided by 5. So 240 divided by 5 is going to be how much? 48 meter per second is going to be the average speed of this object. Right. So I hope it is clear. Right. Whenever you speak about average speed, you need to take the total distance into consideration. Whenever you speak about average velocity, you need to take the displacement into consideration. And the point here is, when I talk about average velocity, the answer is very simple. You need not solve. It is a 0 because the total displacement of the particle is 0. Clear with this? So this is the solution for this problem. Make a note of it. Memory card clear இருக்கா? காலையில எடுத்தாச்சா? Okay. சடனா டவுட் வந்துருக்கு. எதுக்கும் லேப்டாப் வச்சிருப்பேன். Shall I proceed? Shall I proceed? Okay. So let's see another problem where it states the position of an object moving along the x-axis is given by the expression x is equal to a plus bt square, where a is given as 8.5 meter and b is 2.5 meter per second square. One point I would like to mention here is this a does not stand for acceleration. It is some constant. So x is equal to a plus bt square, where the value of a is 8.5 meter and the value of b is 2.5 meter per second square. And t is obviously measured in second. What is its velocity at t is equal to 0 and t is equal to 2 seconds? Listen to this carefully. Whenever they give you a mathematical expression of a physical quantity varying with respect to time, okay? So there are two types of questions that they will ask you. One is at something, one is between something. So when they use the word at, it means instantaneous value. Okay. When they use the word between, it is average value. So I would like to give this keyword at means instantaneous. Between means average value. So in this question, what is the velocity at t is equal to 0 means they're asking instantaneous value. So whenever you want to find instantaneous value, this is the these are the steps you need to follow. So to find the instantaneous value, first, what should I do? First, differentiate. Second step is substitute. Whereas for average, first you will substitute, then you will do it. You will not differentiate, you will find the difference. There is a difference between differentiating and finding the difference. Okay, that I'll explain. There is between also, and I'll explain. I hope this point is registered. No, when they say at, what is that you are supposed to do? First, differentiate. See, it need not be differentiate. Sometimes you can have integration also, depending on what is the question. For example, had they given you velocity and asking you what is the displacement at, then you need to integrate. Okay. So differentiate, or I can say integrate also, depending on the problem. Right. Now, since here x is equal to a plus bt square, differentiating on both the sides, we get dx divided by dt is equal to, what is the derivative of a? Derivative of a number or a constant is a 0 plus b is a constant into, what is the derivative of t square? So which implies dx divided by dt is equal to 2 into b into, what is the, okay, 2 into b into t. So 2 into, what is the value of b? It is going to be 2.5, which is 5 by 2 into, what is the value of time? So first you will find it at 0 second. So when you find it at 0 second, it is going to be a 0. So this is at t is equal to 0. Whereas you find dx by dt at t is equal to 2 second, it is going to be 2 into 5 by 2 into the time is going to be 2. So 2 and 2 will get cancelled. Answer will be 10 meter per second. This is the velocity at that instant, exactly at that instant. Is that point clear? Now, I'll explain how to find the average velocity between t is equal to 2 and 4 seconds. So listen to this. So whenever you need to find average velocity between, in this problem, it is t is equal to 2, t is equal to 4 seconds. When they use the word between, you're finding the average velocity, obviously, right? So V average is equal to delta x divided by delta t. V instantaneous is dx divided by dt. Okay. So whenever you have average value, first step is substitute t, then find the ratio of differences. Is the point clear? So what is the expression? X is equal to a plus bt square. So x in the bracket, what you write is 2. So how you read this is displacement of the particle at 2 seconds. So this is a function. X of 2 means you will take this 2 and substitute wherever time is there. So what will answer be? A plus 4b. A plus 4b. Similarly, x of 4, it is going to be a plus 16b. So this is x1, this is x2. So t1 is 2, t2 is 4. So what is going to be the value of V average? Final minus initial. So a plus 16b minus of a plus 4b, the whole divided by the difference in time, which is going to be 2. A and a are gone. 16 minus 4 is going to be 12b divided by 2. Cancel 6 into b is 2.5, which is going to be 5 by 2. Cancel this and this. Answer will be 15 meter per second. So are you able to understand? Right? So make a note of this. Careful while you're getting a laptop. Done. Done with both the slides? Okay. Shall I proceed? Yeah. Shall I proceed? Yes. So listen. The displacement in meter of a particle moving along x-axis is given by x is equal to 18t plus 5t square. Calculate the instantaneous velocity at t is equal to 2 seconds. Second, calculate the average velocity between t is equal to 2 and 3 seconds. Third, calculate the instantaneous acceleration. Right? So you already know the procedure. I'll give you 3 minutes time, solve that. 1 minute for each point. Right. Right. One more minute. Actually, the problem is not worth 3 seconds, 3 minutes. Instantaneous acceleration. First, you got instantaneous velocity. What did you do? அது நீ வந்து கண்டுபிடிச்ச அதுக்கு முன்னாடி ஒரு எக்ஸ்பிரஷன் இருக்கும் without substituting you will get 18 plus 10t அதை திருப்பி differentiate answer is 10. உள்ள கன்ஃபியூஸ் ஆகும் simple differentiation problem. Videos பார்க்கலையா? இல்ல நான் என் வீடியோஸ் பார்த்தியா? நான் சொல்லி கொடுத்தது. Value substitute. அது ஒரு டவுட் நான் கிளியர் பண்ணேன். டைம் up. Okay. Shall I do this? So first, the instantaneous velocity, differentiate and then substitute. So dx divided by dt is going to be derivative of 18t is 18, derivative of 5t square is 5 into derivative of t square is 2t. So you will get 10t. So dx by dt is velocity, which implies v is equal to 18 plus 10t. Take this t is equal to 2 seconds and substitute it here, which implies v will be equal to 18 plus 20, which is 38 meter per second. Yes, it's simple, right? Second scenario is you need to find between. So when you need to find between, first you will substitute the value of t in the place of x itself, right? So for you to find v average, it is going to be equal to delta x divided by delta t. So delta t is fixed, 3 minus 2. So 3 minus 2, yeah. Delta x is going to be how much? If I take this 2 and substitute it here, let us do the mind calculation. So if I substitute 2 here, it is going to be 36 plus 20. It is going to be 56. So 56 is the initial value. So initial value should be written on the right hand side. From where should it be subtracted? From the final value. When I substitute 3, I get 54 plus 45, which is 99. So you get 99 minus 56 divided by 3 minus 2. So how much is this? 44 divided by 1, which is 44 meter per second. Oh, sorry, 43 meter per second. 1 minute, I'll. So 99 minus 56 is going to be 43 divided by 1. It is going to be 43 meter per second. Okay. Now for instantaneous acceleration, all that you need to do is differentiate the instantaneous velocity. So third one, if I find dv by dt, you will differentiate this. Derivative of 18 is 0 plus derivative of 10t is going to be 10. So answer will be 10 meter per second square. Meaning in this case, there is the acceleration is not dependent on time. So acceleration is going to be uniform. This is another example for uniformly accelerated motion. Okay. Is the point clear? Okay. So I'm not going to go to the next one. I'll just give you a different perspective of understanding this. Listen to this carefully. Did you all copy it? So listen, what is the equation? X is equal to, so x is equal to 18t plus 5t square. Remember this concept, whenever displacement is a function of time square or square of the time, right? It will be uniformly accelerated motion. Because for uniformly accelerated motion, what are the three equations that we have? V is equal to u plus at, s is equal to ut plus half at square. That is there, no? Instead of s, if I write x, if I write x is equal to ut plus half at square, if I compare these two, half at square is equal to 5t square, t square and t square are gone, then a will be equal to, and that's what you got. You're able to understand? So looking at the question itself, you can say, are you able to understand what I did? I just treated it like how you treat a general equation in arithmetic progression. If they ask you something, you'll substitute the value and then do a comparison, right? That's all I did. Are you able to understand? So this is of this format. Suppose in the same question, suppose in this question itself, what is the instantaneous velocity at t is equal to 0? If they ask you, calculate and tell me. You have the expression. What is the at t is equal to 0? What is the instantaneous velocity? 18. So t is equal to 0 corresponds to initial velocity. Am I right? So when you compare these two, what is the initial velocity? That's simple. So even without differentiating, you can pull in some details out of it. Okay. And he had one question. What if the acceleration is dependent on time? What am I supposed to do? Because in this question, it was clear. What is the instantaneous acceleration? Suppose they ask a question, what is the instantaneous acceleration at t is equal to 2? What will be the answer in this case? It will still be 10 only, because acceleration is a constant irrespective of time. It does not depend on time at all. Right? But if at all I need to have acceleration as a function of time, then I'm not supposed to have a second degree equation. Maybe I need to have a degree greater than that. For example, had the question been x is equal to 18t square plus 15t cube, something like this. Okay, just to simplify, I'll make the numbers smaller. I'll just make the numbers simple for you. So x is equal to 3t square plus 4t cube. Suppose something like this is given. Then what is going to be dx by dt? 6t plus 12t square. What is d square x by dt square? Now you will have time present. So whenever displacement is a second degree equation, if it is a second degree polynomial, I would say. Whenever displacement is a second degree polynomial of whom? Of time. Acceleration is always constant. Right here? So this, you can think in this way to validate whether the answer you have got is right or not. If at all you do any calculation mistake also, no? This will always give you a validation. Half a is equal to 5, a is equal to 10. It will match. Am I clear with this? Right? So I want you to copy this. Just write down the heading as alternate way of understanding a mathematical equation. Breathe, huh? D square x by dt square. Then that's how you write the second derivative. If this is a second derivative, need double differentiation. The triple differentiation one every d Shall I proceed? Okay. Okay. So let's look at this problem. The displacement x of a particle varies as x is equal to 4t square minus 15t plus 25. Okay. Find the position, velocity, and acceleration of the particle at t is equal to 0. Find the position. When I need the position, I'll directly substitute 0 here. I'll not differentiate because this is a function of displacement only. When you substitute, you will have 0 minus 0 plus 25. Answer will be 25 meters. So the initial displacement of the particle is 25. Okay. For initial velocity, what I need to do is find dx divided by dt. It is going to be right. You substitute t is equal to 0. No, sorry, not 25. Derivative of 25 is 0. Correction. So derivative of 25 is 0. Now I need the velocity at t is equal to 0. I substitute, answer will come out as minus 15t. Sorry, minus 15. Minus 15 meter per second. If I differentiate this further, d square x divided by dt square, you will get the value as 8. Right? And this is going to be the acceleration at t is equal to 0. Am I clear with this? Okay. Now, the next part of the question is, when will the velocity of the particle become 0? So initially, if you see, the velocity is minus 15. They're asking, when is there a possibility for the object to have 0 velocity? So for that, what I need to do is, I know the expression for velocity as 8t minus 15. Understand the difference. This is the velocity at t is equal to 0. Right? When can velocity be equal to 0? Means you're finding the 0 of the polynomial. Means you will equate the polynomial to 0, then you will get t is equal to 15 by 8 seconds. It takes 15 by 8 seconds for the particle to come to rest. Clear with that? Right. Can we call the motion of the particle as one with uniform acceleration? Can you call it? Yes, you can. Right? Because the acceleration of the object is a constant. Right? So this is all for this problem. Make a note of it. Clear, no? Yes. So 13th question. A jet plane starts from rest. So u is equal to 0 with an acceleration of 3 meter per second square and makes a run for 35 seconds before taking off. What is the minimum length of the runway and what is the velocity of the jet at takeoff? So there is a runway on which what is happening? There is a jet that starts moving before it starts taking off. So how much is the distance it has traveled before the takeoff? So how much time has it traveled in the first place? 35 seconds. So all that you need to do is S is equal to ut plus half at square. Substitute u as 0. S is equal to half into 3 into right? When you calculate this, you will get a value out of this, right? That will be, so that is going to be the minimum length of the runway. Okay, so this is going to be the minimum length of runway. Okay. Second, what is the velocity of the jet at takeoff? Means, what is the velocity here when it started from rest? So what did you say? So you apply V is equal to U plus 80. U is 0, which implies V is equal to 3 into 35. Answer will be 105 meter per second. Is that clear? Right. Sorry? Calculated. How much is it? 18? Point? Okay. 1837.5 meter. Clear? Shall I proceed? Okay. Next one. A driver takes 0.2 seconds to apply the brakes after he sees a need for it. So the 0.2 seconds is basically called reaction time. Okay. Means after he sees something, it takes 0.2 seconds for him to react to it. Okay. So this is mentioned, but sorry, I didn't see the question. This is called as the reaction time of the driver. Okay. So if he is driving car at a speed of 54 kilometers per hour and the brakes cause deceleration of 6 meters per second square, right? Find the distance traveled by the car after he sees the need to put the brakes. So what is the meaning of this? If he's driving the car at a speed, so U is equal to how much? While he started applying the brake, U is equal to 54 kilometer per hour. So this is equal to 54 into, when you need to convert kilometer per hour, you generally multiply it with 5 by 18, which is 1000 by 3600. So just write it as 5 by 18 meter per second. Basically, it comes out to be 15 meter per second. And the brakes cause a deceleration. So what are the brake causing? So A is equal to -6 meter per second square. Find the distance traveled by the car after he sees the need to put. So in this problem, if you see, one thing that we are able to understand is before, find the distance traveled by the car after he sees the need to put. After he sees means after that 0.2 seconds. So after that 0.2 seconds he has applied, then how much will be the distance it has traveled? So it will be V square minus U square is equal to 2as, because time is not there in this problem. So when he applies the brake, right, how much will be the distance that he has traveled? So V will be equal to 0 because obviously the car would have come to rest. Right? U is known. How much is U? 15. So minus 15. It is not minus 15 the whole square, minus 15 square. Okay. This is equal to 2 into deceleration is -6 and displacement is what we can see it here. So minus and minus will get cancelled. It will be 225 divided by 12 is the displacement. So this is the distance he has traveled after he applied the brakes. So just to give you the definition of reaction time, they have given that 0.2. It has nothing to do with this problem. Clear? No, but initially, see, if he is driving car at a speed is a uniform thing only, no? So when he started, initially he was at 15 meter per second square. Then brakes cause a deceleration of this much value. After the need to put brakes, another he sees only he is applying the brake, no? After the need meaning before the need, he's not even applying brake. He's somewhere around 0. It took 0.2 seconds for him to react. Right. No, time is 6:05. Okay. So we'll stop with this problem. So tomorrow's class we'll do the remaining problems. And I'll explain the graphical way of handling things also. So just go through the graphs and come before tomorrow's class. Okay. So any other questions? That's it. Okay, we'll wind up.